right, this is going to be objective 30, logarithmic expressions in exponential form and vice versa. The inverse of exponential is logarithmic, okay? And we talked about that in Algebra 2. In Algebra 2, we just looked at the graphs, we looked at the domain and the range of a logarithmic function. We're actually going to realize, we're going to get into writing them, taking them from logarithmic to exponential, and then taking them from exponential back to logarithmic. Then we're going to evaluate logarithmic expressions, and I could add actually one more into that. We're going to start looking at solving basic logarithmic equations. And we're going to look at, like, why in the world do you need them? Like, what do you use them for? Okay? So that's what we'll get into today. Any questions? Okay. All right, so first things first is, let's look at the exponential form first. B to the y is equal to the x. Okay, so you have your base is b. Thank you. Your base is b. The exponent is y. And when you raise that power to that exponent, it's equal to the x. So if we want to do the opposite of that, or the inverse of that, we go to the logarithmic form, and basically it just says log base b of x is equal to the exponent, is equal to the y, okay? So instead of saying a base to a number is equal to a certain outcome, you're saying the base of the outcome is equal to the exponent. Okay, so you're solving for the exponent. Does that make sense with the logarithm? You're solving for, you're figuring out what the exponent is. Notice, this is how I keep it straight. Notice, this is base b. Over here, this is log base b. The base of a log is the exact same thing as the base of an exponential. Okay, you're just swapping out the exponent for the actual outcome. Okay? Maybe I should put this in number form for you. So just to give you kind of an example, normally we would say 2 to the third is equal to what? 8. Okay, so normally you take the base, raise it to the exponent, you get the outcome, you get 8. Well, basically what I would do if I flipped this around, it would be the log base, what? What's our base? 2. Notice it's still going to be the same base. The log base 2 of 8 is equal to what exponent? 2 to what power would be equal to 8? It would be equal to 3. Does that make sense? And that's going to help you when you don't know the exponent. Does that make sense? You'll be able to evaluate a log, and it'll give you the exponent. Okay. Oh, gosh. I should have just waited for example 1, because there it is. Okay. So we're basically going to take these into exponential form. They're in logarithmic form right now. So let's just review what we just did. If it is the log base 2 of 8, and that's equal to 3, how would I write it in exponential form? 2 to the third power is equal to 8. Here is your exponent. This is your base. And I'm going to call 8 the outcome. What you get when you raise 2 to the third power. Okay? So, how would we do example number 2? How would we take it into exponential form? What does that say to us when it says the log base 3 of 729 is equal to 6? 3 to the 6th power is equal to 729. Any questions on how to read a logarithmic function? Okay. So what we're going to do now is we're going to just do the opposite of that. Okay, we're going to flip it around. I've given it to you in exponential form using an exponent. We're going to take it to logarithmic form. Anybody have any ideas? The log base 15 of 3,375 is equal to the exponent, is equal to 3. Okay? So, I mean, yeah, you could type in 15 to the third and see if that equals 3,375. There is a way to put log base in your calculator. I'm not going to show you yet. I just want you to, if I just show you how to put it in your calculator, you got to trust me on this. If I show you right now how to enter this in the calculator, you're not going to know how to read a logarithmic function. I need to get you really comfortable in saying, okay, this is the base, this is the exponent, this is the outcome. And I know you're like, we got that, Miss Corns, but there's a lot more coming your way in the next couple of days. I really need to make sure you get, so please, 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 even if you know how to do it, don't do it. Okay, I don't want to see any calculators out today. Thank you. All right, here we go. How do we go? I promise I will show you, like very, very soon, how to do log base in the calculator. I promise. Okay. How do we change example 4? The log base 4 of 2, so that's saying 4 to what power is equal to 2? 4 to the 1/2 power. And that makes sense to us. Like, just reviewing from, if it's to the 1/2 power, what is that the same thing of as going back to algebra 2? Well, this actually is like a root. And how do I know what root it is? The root is always the denominator. So what root is that? That's like the square root of 4. 4 to the first, or 4. Do y'all remember that? Like if I have, I don't know, 8 to the 1/3 power, that's the same thing as the cube root of 3, or cube root of 8, excuse me. Okay, so that makes sense because the square root, that says 4 to the 1/2 power is the square root of 4. Square root of 4 is 2. So that makes sense. Okay. All right. So what we're going to do now is we're going to evaluate. So this should go pretty quick. We've already covered part 1 of our objective. Okay, we've taken them from logarithmic to exponential, exponential back to logarithmic. Okay, so what am I asking when I'm saying, what is the log base 16 of 4? I want to know 16 to what power would equal 4? And we just talked about this. This would be the 1/2 power because it's the square root. 1/2, raising something to the 1/2 power is the same thing. So we know that this is equal to 1/2. Okay, 16 to the 1/2 power is equal to 4. Did y'all follow me on that? So what do you think? This says to us 3 to what power is equal to 81? 4. And I'm going to give you these, everything that I give you today, I promise, you know, I've asked you, I'm not going to fuss if you pull out your calculator. I'm just asking you, please don't try to figure out how to do the log base today. Everything I give you today, it's going to be very simple. Like, I don't feel like this was that hard, okay? You just got to think about what number can you times by itself a certain amount of times and get that number, okay? So this says to us 1/2 to what power would equal 256? do you think? Well, let's first of all, what base are we looking at, basically? 2 to, we're looking at a base of 2. Can you tell me what 2 to what power is 256? I think you have it in your notes probably from the other day. Is it 6? It's 8. You have it in your notes from the other day when I gave you all your powers of 2. I gave you that. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. What's 4 times 4? 16. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4 is 16. And 16 times 16 is 256. Okay? So we know 1 over 2 to the 6. But what do I need to do to get this up? So, like, 1 over 2 to the 6 would equal 1 over 256, right? But this is up top. So what would I do to this to get it back up top? 1/2 to what power? The negative 6 power. Based on what we did the other day. Does that make sense? Oh, you're 8. Oh, I'm sorry, 8. Let me go back. I don't know why I think someone said 6 first, so I had 6 in my head. So it would be negative -8. Did I lose you anywhere? Well, when it's in a fraction, as we did, well, carry over what we did yesterday. When it was in fraction form yesterday, what did that tell you about your exponent? You were going to have to take it through the magic mirror, and you were going to have to make it negative. So my base is 2. So I want to know 2 to what power? Well, 2 to the 8th power. But the question is, it's a fraction. So I would be raising this to the -8th. That way, it would move up top and become 256. It would become positive. I would have to move it up top so that it would become 2 to the 8th.
You don't worry about the 1.
Well, I mean, you can evaluate this. You can say, okay, 1 to the -8th over 2 to the -8th. Well, you got to make them positive first, so what happens, what do you need to do to that? He needs to come up top and become 2 to the 8th. What do you need to do to this one? That needs to go to the bottom and become 1 to the 8th. Well, 2 to the 8th is 256. What's 1 times 1 times 1 times 1 times 1 times 1 times 1? 1. And anything divided by 1 is itself. Just know, guys, if it's a fraction, that just means that your exponent needs to be negative. That's what you need to remember, because you're going to need to bring it through the magic mirror. And when it comes through the magic mirror, it will become positive. And it will become what you want it to be. Okay? So, we're going to move into the last part. Any questions on how to evaluate logarithms and figure out what the exponent is? When it gets really difficult or confusing, I will show you how to put it in your calculator. I promise. Okay? So what we're going to do now is we're going to solve basic ones. If I change this into exponential, what would it say? 36 to the 3/2 power is equal to x. Okay, so let's go back and figure out what, then this is a review from Algebra 2. So this is really good for you. If we want to figure out what 36 to the 3/2 power is, and you can put it in your calculator. I don't mind if you put this part in. You could just put in 36 to the parentheses 3 divided by 2. But if you would like to review what you did in Algebra 2, and you need those skills, so it's good to review that. take it to radical form. Okay, in Algebra 2, you practice taking it from exponential form to radical form, meaning a root. What root is it? It's a square root. It's always the denominator. This says to us the square root of 36 to the third power. What is 36 to the third power? You can use your calculator for that. What's 36 raised to the third? 46,656. And then what's the square root of that? 216. So x is equal to 216. Okay. You can do, I'm okay. You can put that in your calculator. You can put that part in your calculator. 36 to the 3/2 power. But I felt like it was good for some of us to know how to go back to radical form. Okay. This number is always your root. This number is always the exponent. So if I made it a root, it would be the square root of 36 to the third power. Okay? Oh, no, just a couple more. We're on part 3 already. So why don't you try this one on your own? All right, so what's another way to say this? 16 to the 5/2 power is equal to x, okay? I'm going to go old school. You can put that in your calculator. 16 to the 5/2 power. What's x equal to? 1024? Okay, that would be fine. Another way to do this is take it to radical form. What root is this? It is a square root because of the denominator, and this is 16 to the 5th power. And then you can, again, 16 to the 5th power is 1,048,000. Too much. It's a big number, and you can just take the square root of that, which y'all said came out to be 1024. Okay. All right. So let me go one step further. I have like 2 or 3 more examples. One step further. If b is a positive number other than 1, okay, as long as b is some other number other than 1, okay, then the log base b of x would have to equal the log base b of y if and only if x and y are equal. Okay? Anybody want to tell me why b would have to be something other than 1? What would, if b was 1, what would that make your base? 1. So if I had, let me ask you this. The log base 1 of, give me some random number. 7 equals the log base 1 of, give me something else. 12. Does 7, are those two things equal? Does 7 have to equal 12 for that to be equal? What's 1 times 1 times 1 times 1 times 1 times 1? It's equal to 1. And is there a way for you to raise 1? If you raise 1 to any power, would you get 7? Because remember, this number is the outcome. No. Can you raise 1 to a certain power and get, do you understand why b has to be something? When you multiply 1, if the base is 1 and you're multiplying 1 times 1 times 1 times 1 times 1, the outcome's going to be 1. So there's no way you can have a base of 1 that would equal something else other than 1. That's why b can't be 1. Okay? But if you have the same base, then, and they are equal to each other, then obviously x and y would have to be equal to each other. So basically, what can you do with your, if you have the same base, what can you do with the log part? Like what we did yesterday, where they just, the bases cancel out, You with me? And you just set the two outcomes equal to each other. Okay. So, let's look at example 10. All right, so do I have the same base? Yes? Log base 2. So we know that if the bases are the same, basically you can cancel out this part and this part and say what? X squared minus 4 would have to equal, in order for the whole thing to be equal, this outcome would have to equal this outcome. Do you understand that? Okay. So then how do I solve that? What kind of equation is that? It's a quadratic. How do you solve quadratics? You set it equal to 0, so I'm going to move him over, and I'm going to put my 3x where? In the middle. How do you solve a quadratic? You can factor it. That's the way I'm going to do it because that looks pretty easy to factor. Okay? You could put it in your calculator and use your spider pig and find left bound, right bound, and find your zeros. You could do the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or you could complete the square for those that like to complete the square. But I'm going to factor it. So, tell me really quickly, x plus 1 minus 4. Now, I'm not done. I'm not done. You got to solve for x. What would x equal? X would equal negative 1, and x would equal positive 4. Okay? I would check for extraneous solutions just to make sure. But when you plug this in, when you square 1, what do you get? 1 minus 4, which would be, so that's going to say the log base 2 of negative 3, and then what's negative 1 here? The log base 2 of negative 3. Will they be equal? Yes. Same thing here. When you plug in 4 squared is 16 minus 4, so that would be the log base 2 of 12, and then 4 times 3 there would be the log base 2 of 12. So they will be equal. It doesn't hurt to check to make sure. That just kind of ensures you did your problem right. Okay? So my question is, I'm going to fix this in a minute, but can you set those two equal? Why not? The bases are not the same. So in this case, you could not set them equal to each other. And I want you to understand that, like when we dive into this more, but I'm going to make them equal. So let's make this a base of 3. Because it was a typo. I'm going to make it a base 3. But I do want you to understand, like, don't just go and start setting things equal when you can't set things equal. Like, they do have to have matching bases in order to set them equal. So what will I get when I factor it? Minus 5 and plus 3. And then that's going to make x equal to 5 and x equal to negative 3. And when you plug them back in, they should work. Any questions about that? All right. The end.